Okay, so here I am. Let's go back to the homework that was due Sunday. Okay, so according to this homework, this is the first problem you were supposed to do. And the difficulty was in the wording, but not necessarily wording, the meaning of those words and how they are placed in your problem. So they are asking for the pH of a sodium acetate solution. So they're talking about, I wrote it here, I'll explain in a sec everything that I have there, but this is your sodium acetate solution. And for this solution, they have, so the way they prepared it is by adding 0.82 grams, here it is, of sodium acetate, which obviously you got to bring to moles all the time, no matter what they ask, you just go to moles, so divided by the molar mass, you have the moles. And then they put this inside 100 milliliters of water, which means 0.1 liters of water, which gives you a concentration of 0.1 molar solution. So stop right there. So this is what they are giving you. Also, they are saying that Ka, so the constant dissolution for the acid, in fact, this is your A, for acetic acid is 1.8 times 10 to the negative 5. But then at that point you ask yourself, wait a minute, they are talking about Ka, and this means I should have an acid in place, which if this is the acid, I dissolve it in water according to the H plus, because this acetic acid breaks down right there into H plus and the acetate anion, right? So when you calculate your Ka should be concentration of H plus times concentration of your acetate anion divided by the concentration of your acetic acid. This ratio will give you 1.8 times 10 to the negative 5. So keep it aside, keep it in mind, and go back instead to what they are giving you. So you have sodium acetate. And right there you stop and you say, well, I got to erase sodium because sodium doesn't change the pH of your solution. Now, why? Well, sodium acetate is made like this. When you put it in water, it dissolves completely because it's sodium, right? And sodium is alkali and completely dissolves. It's a strong electrolyte right there. So completely dissolves and becomes Na+, which keeps on swimming in the pool, doesn't participate with water. And the anion is right there behaving as a base because it's now the acetate minus, right? And sodium, even if put in water, you have the water there, even if sodium would be interested in couple up with the OH coming from the H2O, would not. Because as soon as you have sodium hydroxide, you know sodium hydroxide is a strong base which completely dissociate. So though sodium could be forming an AOH, it just does not because it's not what sodium does. So sodium, you can just erase it. But once you have the moles for the sodium acetate, because the ratio is 1 sodium per 1 acetate, then you know that you also are dealing with 0.1 moles per 1.1 liter, right? A 0.1 molar solution of the acetate. And this is how you start building your table, your ice table. So you start with 0.1 molar solution. Water is a pure liquid, doesn't participate. Acetic acid, as at the moment, you got nothing. OH, you got nothing. Then you go through the change where this one loses X, this one gains X, this one gains X also. And at the equilibrium phase, you have 0.1 minus X for the acetate, X for the acetic acid, and X for the OH. So now if you're putting together the K, which K are you getting? It's not a Ka, but what you're putting together as X squared divided by 0.1 minus X is really Kb because it's the constant of a base. You're dealing with a base, you're not dealing with an acid yet, right? So you need this number instead. Where do you find it? Well, having Ka and knowing that Ka times Kb is equal to the constant of water, and you know that this is 1 times 8 to the 1 times 10 to the negative 14, then Kb is just 1 times 10 to the negative 14 divided by the Ka, which is 1.8 times 10 to the negative 5, And you now have a Kb equal to 5.56 times 10 to the negative 10. And you see that this is a very small amount. That's why here you not necessarily need to write 0.1 minus x, because you know that your x is going to be rather small. So from here you solve for x, but watch out, x to you is OH minus, from which you can calculate, once you have this H and you log it, you calculate POH. And then you do 14 minus your POH, and that's how you find pH, which is 8.87.